In mathematics, a geometric progression is a sequence or series where each term is obtained by multiplying the preceding term by a constant factor. This constant factor, also known as the common ratio, is used to find all subsequent terms in the sequence or series. So to give you a sense of what a geometric series is, let's start with a number, and to generalize things, we'll call that very first number a. Now to find the next term in this series, we have to take a and multiply it by a factor, which we call common ratio. We'll call the common ratio r. So I'll take a, multiply to r, and that will give me the next term in the series. So I'll write down plus a times r. Now I repeat this process to find the third term in the series. So I will multiply ar by r again, which gives me arr. Let's do this 2 more times. So now I'll take this term and multiply it again by r, which gives me arr. And one more time for good measure, we take that and multiply it to r, which gives us a times quadruple r. We'll call this sum s. So we'll add up all of these eventually, whatever a and r happen to be, and that will give us a sum of s. Now to simplify things a little bit, rather than writing factors down as single variables, let's write them down in exponential form. So that remains the way it is, plus ar squared plus ar cubed plus ar to the power of 4. Let's define a variable here. Let's call the number of terms n. So again, we're trying to create a generic formula. So there are 5 terms, and we'll say n equals the number of terms. That's important for later. Now, to come up with a formula that will enable us to add up all of these terms and get the sum of the parts, let's do something to this equation that I just produced. I'll call it equation 1 for reference. And what I'll do to it is I'll multiply both sides of the equation by another factor r. You'll see why I'm doing this in a moment. So if I multiply both sides of this by r, I get SR is equal to all of the right side multiplied to r. So think of this as in parentheses multiplied to r, and if we expand this, we end up with ar plus ar squared plus ar cubed plus ar to the power of 4 plus ar to the power of 5. I'll erase these markings. And we'll call this new equation equation 2. Again, just for reference. What I'll do next is I'll subtract equation 1 from equation 2. So whatever equation 2 was, I'll subtract from it equation 1. Here's what that looks like. So what I did is I simply wrote down equation number 1, which I showed up here, down underneath here, and I'll subtract it from equation 2. If I subtract SR take away S, I get SR take away S, and that's equal to, notice how if I were to subtract AR from AR, they would cancel out. And similarly, if I were to subtract AR squared from AR squared underneath, they would subtract out, giving us 0. Similarly for this one, and for this term, and what we would be left with is the only terms that remain, which are AR to the power of 5 take away A. Now what's interesting about the equation that was formed as a result of subtracting those two is that this 5 actually corresponds to the number of terms. Remember, originally there were 5 terms, and that number happens to be the amount of terms. So rather than using 5, we can generalize that and just say n, because n meant the number of terms in total. So I'm going to replace this 5 with an n, and at the same time, I'm going to factor out a common s on the left side. Since s isn't common, I'll pull it out from the two terms, leaving me with r take away 1 is equal to a times r to the power of 5 take away a. If I divide both sides now by r take away 1, I get s is equal to ar to the power of n take away a over r take away 1. Factoring out an a from the top, we get S is equal to A bracket R to the power of N take away 1 over R take away 1. And to make matters even better, let's put a subscript N to this S, which means that this is the sum of the first 5 terms, or whatever N happens to be, in the series. Let's test this out. Let's say we actually have a series that looks like this. S is equal to, we have a starting number of 2, and we multiply 2 by half. So our common ratio is 0.5. And we keep doing this for the first 5 terms. If we add these terms manually using a calculator, we get something like this. 2 plus 2 times 0.5, and the rest is as shown. We get a total sum of 3.875. So let's write that down. 3.875. Using the formula, we can get there a lot quicker. So I'll write down S sub 5 is equal to, A represents the first term in the series, so 2 times R represents the common ratio, 0.5. N represents a number of terms, that's 5 take away 1 over 0.5 take away 1. Using our calculator again, 2 times 0.5 raised to the power of 5, take away 1, divided by 0.5 take away 1, and we get the same output being 3.875. I hope you found this tutorial helpful. If you have any questions, please use the comment section below, and feel free to support this channel with a thumbs up.